Alright, we've got our index head mounted up here, and back in our video stroke and spline, I believe it was, I did a modification of creating the step up here and creating the millwork so that this chuck lays down and is horizontal and all of that, and how to set that up by dialing a bar in here and getting the right alignment and axis of this mounted on the table. So I'm not going to go through that with you, but I just want to basically tell you that it is square. We put a bar in here, we dialed it already. We went in and tapped a hole into this 1-inch plate that we have here so that it had the right span between here, and we could put in a spacer in here to adjust and have a support out here, just to take the harmonics or vibration out and make it more solid to actually come in and cut the teeth on this gear. Alright, we still have to put the cutter in. We've chosen our cutter. Now this is a 16 diametrical pitch, and the teeth on it are 14.5 degree. It's an involute gear tooth, 14.5 degrees. Now the lead angle of the 14.5, most of the dimensions that we're going to be going and playing with as far as the center line and the working dimension, the height and all of that, is the same as the 20 degrees. The main difference is the thickness of the bottom of the dedendum section of the tooth down to the root. That's where your difference is. The 20 degree is a little bit stronger, and it was basically created and designed for the smaller diameter, the least amount of teeth, like a pinion type of application, where you get down under I don't know, it's probably somewhere between 11 and 20 or so is the critical line of teeth from there on down, that they designed that to create the strength. I'm not a gearhead. I have to look in the book, and I got the book open here to help me out on all of the information that I need to. Basically, I have a sample, so I'm basically going to be copying a sample, and it's easy to measure the sample and create the same measurements on here. But I did open up the book, and by cross-referencing the individual straightforward bits of information that you get from the book, lets me kind of know how much wear is really on the original gear. And that wear is going to come into play when we do the repair on these teeth, because they're broke off at the root, but we're going to have to grind down into the gum of the teeth, or the gum of the gear, get down into this material down in here to actually make a good join bond. You don't want to just stick your braze right to the root of the tooth and try to get away with minimum. That's the biggest mistake most people make in braze repairs. They're just trying to put in the minimum. Get it down in there. Get a good amount of material that you're going to be joining down into the gear itself. We will cover that a little bit more as we go. We're going to go ahead and we're going to hog off some teeth on this gear blank here before we go in and we do the repair on this. Now, as I got out my gear tooth vernier calipers, and I'm kind of lucky because the 16 diametrical pitch is about the smallest pitch that this comfortably measures, because of the limitation of the depth that this particular pair here only goes down to about 59 thousandths on the depth measurement, so that you can measure the working pitch circle where it splits the addendum and the dedendum. It's pretty close to being halfway, but the addendum is a little bit shallower than the dedendum. But the dedendum also has a little bit of clearance where the top of one tooth goes in, and the clearance between the bottom of the root and there is kind of where I think the little extra is actually at. Other than that, probably the amount of working surface. And I'm, like I said, I'm not a gearhead. I'm just logically explaining what I do know as far as the working area. In the comments there, I had mentioned about sliding together. Gears don't slide. Their pressure points are in direct line, but as the gears roll, that contact surface does change from one section of the tooth to another section of the tooth as the pressure and as the rotation of the two mating surfaces move. That line works from down into the gear to up on the top of the gear, as far as that surface, the pressure angle surface. I just wanted to, I slipped up and it said sliding, and it wasn't the right terminology. I'm a much better walker than I am a talker. So anyway, I took the tooth, and actually this is two things you need when you're using this. I don't know if it was when I was youth it was as much important, but you do need to have a magnifying glass so that you can read these things. And also I find that holding it up and visually seeing the light gap behind like the top of your tooth and the blade, the depth blade and things like that, to make sure that you are in fact at the right location. And then it did confirm that this gear, by the book dimensions, has got a couple thousandths worth of wear on the width, and over the period of time it does have a little bit of wear. But it also does confirm that I do have the right gear cutter, and I also was able to go ahead and pull this out when I got it and actually take it and physically hold it up and verify that I do have the right cutter as well, and also see a slight bit of wear. But it definitely, the main importance is making sure that you do have a 14.5 pitch when you need it, or a 20-degree diametrical pitch cutter to match what you're actually trying to cut. Alright, we're going to get this mounted into there, and we have what we did is we took the width of this, and we took the diameter of this minor diameter here of this shaft, and we're going to take our cutter and come off the table with a square along this surface right here, and light behind the side of the cutter, and we're going to match those, and then we're going to just travel over the distance that creates center line, which will be 334.5 thousandths to 335. We can split it between the half a thousandths there. It's that'll give us the center line for the cutter to ride, and then after that we'll go ahead and we'll be able to get up here. We've got to go ahead and change our our pin location here. We have the book for our dividing head, and in here we've already researched. We always research in here before we take on a gear job anyway, to make sure what we have, and we've counted the teeth in our sample, and we have 78 teeth. So 78 comes down here, and we use the number 1 plate, which we have number 1 and we have number 2 plate. We're missing 3, 4, 5, and 6. So there's 6 plates set that actually go with this head, and I only have 2, but I do have the most common 2. And you have to have the correct disc. You can't just any dividing head is not gonna match up or be the same. It has to be the same model and the same manufacturer. So with that said, the 78 hole pattern is the third one down here, and each increment of tooth is going to be 5 holes. So we're going to go 5 holes each tooth, and it'll be 5 complete revolutions around on this. This is a 5 to 1 index head, and that's why this uses, I believe it's 5 to 1. 5 to 1 or 10 to 1. Well, I'm not gonna look for it right now, but I do know it's either 5 or 10 to 1. And what leads me to believe that it's 5 is because this index head can actually do 5 points by 5 revolutions to give 1 on the head. So to me, that's 5 to 1. Okay, we're getting ready to loosen this and change our pin. We're going to drop our pin location down to the third hole set here. Actually, I gotta lock this and break that loose. 78 is our hole pattern. So we leave this loose and we rock this back and forth because you need it to slip in and out of the holes easy. So it is important, and that's why this is a taper fit here, and we actually got to pull this taper off of here because we have a dial or a fan that we take the span of our number of holes and create the position so that we can slide it against our pin and then move, and then slide it against our pin and move, and that's our mental marker for our 5s, our 5 hole location, and that's what we're going to be on. Alright, so we go ahead and we lock this down, and it fits in there fine. Let's just make sure it fits in every other hole fine. Alright, now alright, we got to break this nut loose here because we got to go ahead and measure a 5 hole pattern here. And I need to get my heel bar here. Okay, it shouldn't be on that difficult there because we don't draw it up that tight as it is. Okay. You don't want to lose that spring and all of these goodies. Okay, straight screwdriver. I need to get that. And we're going to go ahead and this is 78 circle right there. That's the circle we're going to work. There's 1, 2, 3, 4, and there's 5. So our fan blade has got to be in there. One, two, three, four, 5. Okay. Now what I always do, because I need to visually see it, and I know that it's not going to come all the way around and come back to this position right here because increments of 5 into 78, just not devised that there's like a remainder of 1 or 6, something like that. Okay, so we're gonna We're going to paint that one. Paint that one. Paint this one. There's that one. Every 10th one is really drawn on here. It's got a highlighted circle around it. Make sure you stay on the right row as you're going around here. Okay, see it comes around there. Now the next row around is actually going to be two off. So you mentally know that you need to rely on that span, because then you're going to be coming off of another mark. So you're not hitting every mark right here. But you do have to follow every 5 holes. After 5 complete revolutions around this thing, we will be back up to our 0 mark. Okay, so I've already hand rotated it around, and I kind of got that in my head. So now that you kind of understand the pattern that this will come, and we'll probably be going around this thing several times. We're not going to do this all in one single cut here. Alright, so there's the first, there's the second, there's the third, and so on. When we come around here, then you're going to know that you're going to be like 2 past each hole. And then the next time you come around, it'll be in a different position. And then by the time it comes around, and you'll be seeing that you'll be coming up, and you'll finish up in the same hole that you started with, and you'll be back up the first tooth, or the first valley. There are as many valleys as there are teeth, otherwise the system wouldn't work as well. Alright. So we're set and we're locked there. I was thinking of whether we're going to want to time this with that key, and I'm not going to bother with that. When we get all done cutting the teeth, I'm going to put the 2 gears together, and then we'll create the whole pattern of all of this in relationship to that key. That'll be as close as the balance of the gears out here should be irrelevant to this balance that we're creating here for the attachment that bolts to this. Alright, let's get this book and a couple things out of the way here. We will get in and get a look at the literature on the information that I'm actually looking at in the book in relationship to what we're cutting, and I'll have all of that up as we're going. I just want to go ahead and let's go ahead and do the setup of getting the cutter in. I've already cleaned up this little bar. I don't have a long 1-inch number 40 taper drawbar. All I have is this short stubby here. So I'm going to go ahead whenever I tighten a cutter on, I pull to preload the torque or the cutter working load against the keyway. so it doesn't have any space to get a momentum up and then into it. Okay, now we'll go ahead and give it a little bit of oil here on the waist because we're going to be bringing it up and in pretty clean. It's not immaculate, but I do want to put some oil on it. Okay, and we're going to come up a little bit. We're going to come in. And we're really hoping that we can get to center without having to move this thing too much. Okay, we're actually still good. We have to loosen this up. We have to get our cutter out in front of there. That means we're not going to be running the cutter on the keyway. We're going to be actually hanging it out past the keyway. Okay, so we got the universal head up here, and we had an option. This is the simple way to go ahead and run this. We could put this, flip this over, turn this over, and redial this in two directions, but it normally is set here or horizontal, and with it set over here, I am actually able to come over past, center past in the gear here, and I'm still within an inch of my full travel. This is where all the weight is, and there's nothing out on that end of the table, so why not go ahead? I can do this gear right here, and the only difference is we're going to be feeding in instead of feeding up. So first off, we're going to go ahead, back this up here, and we're going to get our arbor in here. Now that we know that we weren't able to go in, we can take the arbor as long as this height, the center, and this clearance right here remains, you know, good, then we'll be able to do that. If not, then we will have to move it one more time, and that would be to put this over on this side here and move everything out. I threw the rag on my wrench there, that's the problem. We're going to figure out how we're going to go ahead and get a line from here over to there. We put a parallel on here, and we're going to go ahead and we're going to crank this up. To where we're just touching. Right there. Okay, we need to go up an additional 334 and a half or 35 to be exactly on center. Okay, that's 250. Okay, we need 34, which would be 8. 85. Okay, right there should be center. My eyeball, it verifies that it is center. Alright, we're going to pull our ankle off because we're not going to be changing up and down at all. Our knee is locked, tight enough. Okay. Alright, we're going to come out, we're going to come over. We're going to come out some more. Sure that we can go all the way past. We can go past, and we're all good in here. We are going to be going that way a little bit, but we are still going to be able to have the clearance. We're going to be setting our stop so that the stop will kick our part out. Got to go a little bit more, grab a little bit more, so we're going to give it about another 1/4 inch. That way this can turn into a no-brainer type of, just a little bit more. Okay. That will stop. Check our rotation. We need to change direction. We need to slow her down. We're going to start out there. Alright, we're going to get a large rag towel all put in here so that the cast iron material will drape into it and we'll be able to catch it. Alright, once I get that done there, then we're going to come back and I'm going to get you in a good position here and we're going to start cutting. Okay, we're looking, we got the book open out on the table here, and the full working depth of the tooth is 134 and 8/10. I think we'll be just lucky if we get 134 plus or minus 1/1000. But I've got the book here, so we're going to go ahead knowing that we got 134 and 8/10. We still need to go ahead, and we know the circular pitch from one tooth to the next tooth is 196, and (196) is basically from one tooth to the next tooth. From, you know, that's the pitch from one to the next, same spot, same spot. So we need to touch off, make a mark index it, make a mark, and measure and confirm that we're doing this. This is, you don't want to do 78 teeth and find out on the 77th tooth that you don't have enough room, or you have enough room to put 2 teeth. It's really good to make sure that when you come around, you're going to end up in the same spot. Alright, let's go ahead and fire it up. We're going to touch off, and we're going to set our dial at 0 here. Okay, there's touching. So I'm going to set my inward travel at 0 right there. Then I'm going to go ahead and I'm going to give it, like 20,000. And then I'm going to come across this point, and then I'm going to index it. Now I'm just kind of cranking this by hand here. Alright. Loosen up our brake. Go 5 holes. Tighten our brake again. Go ahead and bring it up here to see where we're at and get a good measurement on that width. So I go ahead and I take my pin, disengage it, and I can hand crank that up here so that I can look at it. And we have, like right at 200, which would be, or a little bit less than 200, but 196. So I'm probably 4 thousandths off on my reading my scale here. Let me see. Okay, I can see that it's just under the 200 with a magnifying glass. So I'm going to take it that I am on the money. Now we're going to rotate this back down. There's our first hole, or our first tooth, right there. We're going to lock it down. And I'm happy. Okay, I brought you in close here. You can see the first cut. I'm going to go ahead, I'm going to crank in 100,000. I'm going to go around and give each one of these 100,000s on the depth. Feels pretty stout. It feels like I'm cutting on at least 75% of the teeth around there at half an inch feet rate. I'm going to jump it up to 5/8. Okay, 3/4. Okay, I think I can feel almost every tooth hit that with some kind of a load. Okay, we're done cutting, and my handle's just tripped out. All right, we're going to take the brake off, and we go ahead and we index it 5 holes.